Good evening, everyone. Welcome to Lowell Observatory's live stream. This is our interactive stargazing. My name's Jose. I am an educator at Lowell Observatory. I've been with the observatory for about 5 years. I studied astronomy and physics at Northern Arizona, as well as mathematics at Arizona State. And honestly, it's a pretty great place to work at. So I'm actually sitting here in the historic Slifer building doing this. But what we're looking at right now is we got one of our telescopes at our brand new Giovanni Open Deck Observatory. Right now it's just pointed at a star, but we're going to be using this telescope to photograph and view various night sky objects. And so, of course, throughout the night, you can request if you want to look at something specific. You can put in a request, and I'll go ahead and we can move the telescope and look at it. So this telescope that we're using, this is a 14-inch plane wave telescope. It is one of our newest additions to the observatory. So the Godo, right, as we like to call it, the Godo, it opened up for the first time to the public in October of 2019. So yeah, so we're gonna go ahead and move to our first object. I have a few things that I want to look at, and then we can start taking on some requests. So we're going to look at M16 first, which is called the Eagle Nebula, and you'll probably be able to see the telescope moving. So the plane wave telescope that we're using is the one that's going to be all lit up in red in that view of the Godo right there. And this one has a camera attached to the back of it, and we're going to be taking some long exposure photographs. Right? So this is called the Eagle Nebula. This is one of my favorite nebulae to look at least with a long exposure photograph like this one right here. So one of the reasons that it's my favorite is because of this very interesting feature, which we call the pillars of creation. So what you can see is we're zooming in really close to the pillars of creation right there, so we can see it. And that is a big cloud of pretty much interstellar dust right there. You can see it's got a little bit of highlights in red, but most of it's pretty black. And then the telescope, not the telescope, the object itself is what we call, it's an emission nebula. This is a star forming region. And we can actually find this in the constellation Sagittarius, I believe, or Serpens, sorry. So this is a enormous gas cloud, right? This is an enormous gas cloud far off in outer space, about 6,000 light years away from us. Pretty far. Don't attempt to drive there, right? And what's happening with this is it's actually collapsing in on itself. It's become so massive that it started to collapse down, and it's forming hundreds of stars. And this dark area right here, this pillars of creation, which is a very famous feature. Like if you Google, I feel like if you just Google space, you'll see the pillars of creation. Maybe don't prove me wrong, but right. So you can see this right here. And what you see is it's really dark, right? And the image that we're taking, is a invisible light. That's the kind of camera that we're using. So it's going across all visible wavelengths. So if you were really close to it, you might actually see it like that, right? And it is about 5,700 light years away right now, right? So this right here, this is a cloud of dust. And I could probably talk about dust forever and ever. But what's so exciting about this is that while it looks like there's not very much in it, it looks kind of empty, kind of black, that is actually filled with thousands or hundreds of newly forming stars. And the starlight is unable to pass through that dust because the starlight's going to be about the same, the wavelength is going to be about the same size as these little dust grains. So they get scattered and it gets blocked and we can't see it. Now, if we had any better telescopes, and when I say better, I mean a telescope in space right now, we would be able to take images in infrared and you would be able to see those stars because the infrared radiation is able to pass through that dust quite easily since it's much bigger. So this particular nebula, as I said, is collapsing down. It's forming new stars. As it collapses, the temperature rises and we get higher pressure in these little dense clusters of gas. And eventually we get this process called nuclear fusion. And that's what stars do best, right? Is they fuse heavy elements from smaller elements. That's so we have uh, basically brand new stars. They could be in the thousands to millions of years old. Incidentally, thousands and millions of years old is young for a star. So, uh, so we are going to be doing some longer exposure lengths. I believe I can't actually tell what the exposure for this particular image is right now, uh, but it's probably it's 14 seconds, which is actually right down here at the bottom, which I've forgotten. That's where you can see the exposure time. So they're going to be in the tens of seconds, not going to be very long at all, right? And yeah, so this is a 14-inch telescope, and we can get some of those fainter objects pretty easily without any trouble. So someone has asked what the F ratio was for this telescope for the 14-inch plane wave, and it is an f7.2 F ratio for the person who is interested. All right. All right, so we're gonna go ahead and move to the next object, if everyone is okay with that. I really like the Eagle Nebula. I like star formation. We're going to move to M27, which is actually my favorite deep sky object. And it's mostly my favorite because there's a little bit of nostalgia that I have with this. When I was studying at NAU about 3 years ago, I took this class called Observational Astronomy. And my class was very lucky. We got to do some observing at the Lowell Discovery Telescope. And we took an image of this and actually the Eagle Nebula, now that I remember. But we took an image of this one, and I was pretty excited about it because it was a full moon, and I wasn't expecting us to see very much, but it turned out to be a very good picture. One that I keep on my phone so I can share it with people. But here is the plane waves version of the Dumbbell Nebula. Looks like we're doing, again, 14 seconds. So the Dumbbell Nebula is a planetary nebula. Now, it's kind of a misconception when we call them planetary nebulae because you're not going to find any planets in here at all, right? Excuse me. So the reason that we call planetary nebulae is there's two stories that I've heard, and I'm not entirely sure which one is true, but I think they're both really fun stories. So the first story that I have is comes from William Herschel. So William Herschel famously discovered the planet Uranus, right? And some other really neat things as well. But while he was, discovering lots of deep sky objects, he kept finding a lot of these little kind of blobs, and they kind of looked like planets. But the problem is unlike the planets, these little nebulae, they stayed still in the sky, right? The planets, they move through the sky, they change constellations, but these ones were not. So he knew they were not planets. And so that was one reason why it might have been called a planetary nebula. Another one that I've heard about is that when these were first getting discovered, people weren't sure what they were, and they thought maybe they were nebulae that were forming into planets. And of course, we now know that is not true either. So the reason that, what this actually is a dead sun. So this star was a lot like our sun thousands of years ago. I can say thousands of years ago pretty confidently there. And so after a star has formed, right, it's got this nuclear fusion process happening at the very center. And the hottest part, we have small elements smashing into each other, forming into bigger elements, right? They're releasing a lot of energy, a lot of light, a lot of heat, right? And this process, depending on the size of the star, can happen. It can take a long time. It could take thousands of years or or sorry, millions of years, or it could be billions of years for this process to happen, right? So a star like our sun will fuse heavy elements for 7 to 10 billion years. And our sun's about midway through its lifetime right now, so we don't expect it to become a planetary nebula for a very long time. So, excuse me. So what happens when a star gets old as it ages, it starts to become unstable. We have these dueling forces happening within the star. We have gravity pushing inward, the star constantly wanting to collapse in on itself. But we also have this radiation pressure pressing outwards. It wants to explode. A star like our sun, it's in hydrostatic equilibrium. It's both of those forces are equal. It's staying the same size, right? So that's good for us right now. Now, as it gets older, it's going to start to become unstable. One of those forces is surely to win. And what happens here is we start to get this star. It goes through this variability where it grows and it shrinks and grows and shrinks and it starts to push out layers and layers and layers of gas until we don't have the energy to fuse heavy elements anymore. So we have the dense hot core, which we would call a white dwarf, surrounded by this cloud of gas, which is what we're seeing right here with this image. So, just some features that I want to point out with this particular nebula. So there's two planetary nebula that are pretty famous that you can see during the summertime. There's this one, an M57 the Ring Nebula, right? And this one, I prefer, although the M57 is a little bit brighter and looks a little bit better if you're going to look through a telescope, but I have my favorites, right? And what we can see is we can see this outer red ring, right? And then we have this inner green gas. And there's at the very center, we have a white dwarf. And let me see if I can point out which one is the white dwarf. And it's, yeah, that one right there. Thank you very much. I was about to just mark it, but yeah. So at the very center, we have this white dwarf, and it's not really a star anymore. It's not doing heavy element fusion anymore. It's still really hot, and that's residual heat from the collapse of the star, and of course, just the lifetime that the star lived. And over time, it's going to continue to cool down. It'll take trillions of years for this star to cool down until it's no longer glowing and no longer shining. This gas cloud that surrounds it, however, that's going to dissipate over time. It's going to spread out into space, and maybe in 100,000 years, that will be gone, right? But the white dwarf will still be there. Now, if we had an infrared camera, which we need a telescope in space for, right? If we had an infrared camera, we'd actually see another layer beyond this red layer, which is going to just be more and more dust. This thing you can imagine, I can't remember the name of that character from Charlie Brown, the one who's like really dusty, right? You can imagine, right? You can imagine it's kind of like that pig pen, thank you. Yeah, imagine it's like that character with all the dust around it. But again, when we're looking in visible wavelengths, most of that light we can't actually see. So now the components of this nebula, that red is going to be some dust, but we're also going to have some hydrogen in there. And then the green, that's going to be ionized oxygen, right? So ionized oxygen meaning that it's lost an electron or and that gives that greenish color, which I think is absolutely pretty. All right, we're going to go ahead, and if nobody has any questions about the Dumbbell Nebula, I'm going to be sad to see it go. But we're going to move on to the Veil Nebula now. So the Veil Nebula is a rather large nebula. It takes up a lot of space in the sky anyway. So we're going to look at part of it, right? And you can see Sarah, who's operating the telescope. You can see her doing that right now. So we're going to move to this, and this is actually a supernova remnant. So once we get this image taken, we'll be able to see it. You can see that we're doing 16-second exposure images now. And we'll have a better one coming up in a second. Looks like the camera was still moving, right? But you can start to see the beginnings of it, right? You can see little bits of nebulosity. You can see little gas that are a little bit red and a little bit green, right? And so this is just part of what we call a supernova remnant. So, so a supernova remnant is kind of, I'm not going to say the opposite of a planetary nebula, but it's definitely not the same thing at all. So stars, as they live their lives, they have two possible deaths that they can go through. Small stars like our sun is considered a small mass star. Those ones are going to eventually become planetary nebulae, like the Dumbbell Nebula. A supernova will happen with large, high mass stars. So these stars have to be 10 times bigger than the sun or more. They got to be pretty massive. And these larger stars, they're going to live shorter lives than a star like our sun. It's going to probably live 100,000 to 1,000,000 years, 10 million years before it goes supernova. And the only reason that they have shorter lives is because they have so much more mass, they have a lot more energy. They're actually fusing those heavy elements a lot faster. They burn through their material faster. Whereas our sun, it's just taking its jolly sweet time while it does this. So when this star gets old and it starts to get unstable, its core is going to suddenly collapse. And as this core collapses, it causes a chain reaction, right? So the segment of the veil, I believe this one is the witch's broomstick, I believe. I don't believe it's either east or west. But yeah, unless, no, right? So when the star collapses, this core collapses, it causes this chain reaction. It collapses so quickly that all of these heavy elements that are falling in towards the center is actually the Eastern Veil Nebula. Thank you, Sarah, for that. Right. So it's going to cause a chain reaction, and all of these little heavy elements, they're going to start to bounce off the core. There's basically no room left for them. And it causes a major explosion. So a supernova is my favorite my favorite event in space. It's probably the second most energetic event to happen in outer space, second only to gamma ray bursts, right? They are incredibly hot, incredibly bright. All of the heavy elements that we find on Earth were created during a supernova event, right? There's enough heat and energy to fuse some of these heavy elements. And they're usually, if they're close enough, they can be bright enough that you can see from Earth. Fortunately, those don't happen enough or don't happen often enough that we need to worry about them, right? This particular supernova happened like 20,000 years ago, so no one was around to see this one, right? But there's a few supernovae that have happened over the past 1,000 years or so that have been like written down and noted. And they usually kind of just look like bright guest stars. And then they eventually fade from view entirely. So this one happened long enough ago that all of the guts that were being spread out into outer space, so all of this is star guts, right? They've had enough time to spread out over a big enough area that we can't even see the whole thing in one go. We'd have to, take lots of pictures and then piece them together. So we can see a couple colors here. We got some, I think it's green, right? We got some green. We got some red. That tells me that there's going to be some more hydrogen in here. There's going to be some oxygen. We can also find other heavy elements like iron and sulfur and all of the delicious things we find here on the surface of the Earth, right? All right. So I'm going to go ahead and move to my next object, and then we can move on to, there's some requests that are already coming in, right? My next object that I'm going to do is going to be the Whirlpool Galaxy, or M51. I really wanted to get this early in the night because it is a little bit farther to the north. It's near the constellation Ursa Major in the constellation Canis Venatici, so the hunting dogs. So what happens is later on in the night, it goes behind our building. It goes behind the Godot building, so it goes out of view a little bit earlier than I would like. So this is the galaxy right here, and once we get some of the higher, a little bit higher exposure going on with that, we can talk a little bit more about it. But you can see right away there are two bright points, and those two bright points are the centers of two different galaxies. So the nucleus is always going to be the brightest part of the galaxy, unless there's a supernova, because supernovae are usually bright enough that they outshine the nucleus for a while. But what this is one of the more famous galaxies. Sometimes I've even seen this used as an image of the Milky Way. Since we can't photograph the Milky Way because we're in it, we'll often use images of galaxies that might look similar to sort of get the picture across. Right, so this is a spiral galaxy, or a grand design spiral galaxy, actually, because of its uniform shape. It's perfectly face on with us, right? We got that bright center. And then, of course, we can see those beautiful spiral arms. And those spiral arms are a little bit blue right there. There's a lot of hydrogen gas in these spiral arms and a lot of dust. You can actually see some of that dust in the arms as well. And there's a few bright stars, and most of those are going to be foreground stars. But some of them do belong to the Whirlpool Galaxy as well, or they might be clustered. Right. And then, of course, over to the right-hand side, you can see this other galaxy. And what you might already have noticed is this Whirlpool Galaxy is slowly stealing stars off of this little tiny dwarf galaxy. And in a couple million or billion years, this little dwarf galaxy will cease to exist. When we see a bigger galaxy eating up little galaxies, we call it cannibalism, which I don't know, I think it's so funny, right? Yeah, so one of the things that I recently just learned was the nucleus of the Whirlpool Galaxy is actually an active galactic nucleus. That means that the black hole at the very center is still growing. It's still taking in matter, and it's going to be a much brighter nucleus than you would see in an inactive galaxy or a quiescent nucleus. With the Milky Way, it is not active. It's not taking in material. So we don't need to worry about that here in the Milky Way. But it does make a really pretty galaxy as well out there. Right. So this particular galaxy, I think it's about 20 million light years away, and it's about half the size of the Milky Way. And I'm not including that little dwarf there, right? I'm just including the main large spiral galaxy that we can see, right? Interacting galaxies interest me a lot because we can see a lot of like kind of action that's happening in here. You can sort of tell it's very faint, and you can sort of tell kind of like right around this area, you can see it's actually a little bit lighter, but it's kind of fuzzy, and that's all stars. And what's happening with these galaxies is as they're interacting, stars are getting flung out into the outer reaches of space. It kind of helps with canceling out any momentum that might be changing. Right? So, uh, so Sarah has just put it in a negative view, so we can see some of these. You can still see it. Yeah, right there. Looks really nice. So we have a really good night for viewing tonight because we don't we don't have the moon or anything getting in the way like last week, which is convenient for me because I like talking about galaxies a lot more, right? All right, so I'm going to move on to the requests. We've already got quite a few in, so I'm just going to go in order, right? So we're going to move right on into Comet Neowise. So this one might take a hot second just because this comet, which you might have heard about in the news, you've read about it, it was visible last month, or to the naked eye visible last month, but it has since faded. At least I can't see it anymore when I try to look for it. But because it's a comet, it's not a deep space object, and it's also not a named object in our program, we have to enter the actual coordinates, which is what Sarah's doing here. So in space, we're going to use coordinates right ascension and declination, as opposed to lat and long, even though they're very similar, like, right? So she's entering those coordinates. This comet has a really long orbit. I don't remember, pretty sure it's a couple hundred years, if I remember right. So this is like the only time any of us are going to see this comet come around. It goes out into like the farthest reaches of the solar system. And it's near parabolic, meaning that it almost just orbits the sun. It could orbit just the sun just once, but as far as I'm aware, it is not, right? It goes in very close to the sun, and so it's on its way towards the sun right now. And you can see the image has shown up here. We got this absolutely beautiful blue color at the very center where it's white. That's where it's going to be the brightest. That's going to be the coma, right? That's the core of the comet. And then we have this gas around it. As it gets close to the sun, we have all of this heat from the sun basically bombarding this comet here. As the ice, which is what comets are made of, ice and dust, it's going to start to sublimate or change from a solid to a gas, and it will start to leave this trail of ice behind it as the comet passes through the sky. And you can actually see the direction of motion for this comet. So you can see Sarah's using her little cursor there to highlight the comet's tail. Comets typically have two tails. There's a dust tail, which I don't think we'll be able to see with this, and an ionized gas tail, which is what we're seeing, that blue glowing tail right there, right? And the dust tail will follow the direction of the comet's motion, but the ionized gas tail, that's going to follow the direction of the solar wind. So this is interacting with the solar wind and it's essentially blowing it away, right? So you can actually see that. It looks really nice. This isn't my first comet that I've seen in live or with the naked eye as well. I have seen two others. A couple years ago, there was Comet Virtanen or Wirtanen, depending on who you talk to. That one was naked eye visible. We looked at it here at Lowell that winter. It was 2 winters ago now. Was a really neat comet to look at. And then, of course, in the early 90s, Hale Bopp, I vaguely remember seeing as a kid. It's kind of cool. So yeah, this comet Neowise, it was visible naked eye last month, but it is slowly getting darker and darker. So it's going to go away. So this is kind of a once in a lifetime chance for us. So I'm really glad we got to see that. Right. And someone asked if it had hit Mercury, would we feel anything on Earth? So I am unsure if that we would. I think we would not feel anything on Earth. Mercury is far enough away from us, although it probably makes for some good observing for planetary astronomers, that's for sure. Right? And then, all right, so the next object is, we're going to look at the Crescent, which I think is a nebula, right? Crescent Nebula. So we're going to go ahead and move to that. So it is taking a 21-second exposure image, so there's a little bit of wait time that we gotta just to see the image, right? On the next image, 21 seconds from now, that one's going to be a lot better, but you can start to see a little bit of that nebulosity kind of passing through the center of the screen here. Now, I haven't seen the Crescent Nebula. I'm unsure of what that one is. So, but it looks like it could be either a supernova or a star-forming nebula. So This is actually gas spreading off of a Wolf-Rayet star, right? Um, and the comet was blue. I don't remember why it's blue. I think it has a lot to do with what it's made of, right? But yeah, so this is spreading off of a Wolf-Rayet star here. And now I don't exactly remember what Wolf-Rayet stars are. I remember they're pretty important. I remember learning about them in astronomy classes, and I know that we have a astronomer here at Lowell Observatory, Phil Massey, who studies them. So they're going to be high mass stars for sure, right? I've observed a few in my time as an observer at the observatory, right? And some Wolf-Rayet stars that we've had in Andromeda. But yeah, so this is the Crescent Nebula, real pretty. Right, we got some reds and again some reds and some greens or blues there, which tells me that that's probably some high-end hydrogen gas and oxygen that has been ionized by the star itself. So usually what happens is when there's a star that's enshrouded in gas like this, it's going to its energy is going to pass through this gas. The little electrons are going to get all excited and they're going to start to give off light, right? When they change energy states. So that's usually how we see these nebulae is because of these little electrons that are in excited states. Yeah, so the Crescent Nebula, thanks for showing me that one. I hadn't seen that one before. I'm really excited about it. Right. Oh no, I lost my place on the list of the things that we have to look at. Right, so yeah, we just looked at Neowise. We're gonna go ahead and we're gonna look at M53. Right. I'm trying to remember which one M53 is. I take a lot of notes, but if you gave me a Messier number, I'd probably be like, I don't remember which one that one is. Once I look at it, I'll probably be like, oh yes, that one. Right. So it looks like a little globular star cluster. It's a cute little guy, right? So let's get some higher exposure up in there so we can see more of the stars. That's certainly not all of the stars we're going to see. Right? Yeah, I, for some reason, don't have anything about M53 in my notes, but I can tell you about globular star clusters, right, pretty easily. So they range between about 25 and 35,000 light years away from us. So a pretty big range. But we find these globular clusters, there's probably about 200 of them in the what we call the halo of the Milky Way galaxy. So it's not exactly in the plane of the galaxy, it's going to be near the nucleus, but sort of above and below the plane, right? So we find a whole bunch of these star clusters. And it's actually kind of still a mystery of like how they formed, but there's a lot of speculation. One of the ideas is that it might be they might be little tiny galaxies who got cannibalized, but their cores, which are so incredibly dense, they kind of just stuck together, and so now that's why they're hanging out in the halo, right? Most of these stars are going to be very old. So I'm actually interested in this particular image. I don't know if it's the color or the specs that Sarah's using, but most of the time we'll see these stars as really red, but we're seeing them very blue right now. And so, but these are going to be very old, like red dwarfs or red giant stars. They're going to be in the billions of years old. So far older than our sun. Our sun's about 5 billion years old. We can expect these to be about 10 million years old. But yeah, this is very blue, which is a lot different. The blueness of it might tell me that these stars are actually still a lot younger. They're certainly a lot hotter and a lot more massive than stars I've seen in other globular clusters. Now, these usually they can vary, but they'll have in the thousands of stars that they have as part of these clusters, right? And it gets denser and denser towards the center of the cluster. Right? Now, when we look at these through the eyepieces of telescopes, when we're normally open to the public, we'll look at these, and I like to describe it as glitter, right? Kind of like someone like threw glitter at the eyepiece. I've had people describe it as like dewdrops. They're some of the prettiest objects to look at through a telescope. Some of my favorite objects are globular clusters. Globular clusters are actually kind of interesting because of their range and where they're at, we can use them sort of as standard candles, right? Standard candles are objects in space that have a set luminosity or a set brightness to them. Right? And you can determine distances of objects if they're standard candles pretty easily because you know how bright it's going to be, and so or how bright it's going to be when you're right next to it. And depending on how much light you get from it here on Earth, how much is extincted, that's going to give you a pretty good idea of what the distance are. And we've used this and globular clusters to determine this, the location of the center of the galaxy, which we know is in Sagittarius, where there's actually a black hole at the center, right? So globular clusters are very important when it comes to mapping our location in the galaxy itself. I'm really excited I got to see this one. This one was really pretty, M53. Yeah, thank you for that one. We're going to go ahead and move to the next object. All right. So it looks like we got a comet called Lemon with 2 M's. I don't know if we can look at that one or not. So all right, we are going to look at that, but we're going to look at it a little bit later because again, it's a comet and it's not like you can't just type it into the coordinates. We're going to have to actually find the actual coordinates. So these 2 comets, Lemon and Pan stars, we'll do in a minute, but we'll move on to we'll go ahead and do M17. If I remember right, that's an open star cluster in Sagittarius, which I think this will be my first time looking at it with the Melon cam. Right? Oh, it's the Omega Nebula, or the Swan Nebula, right? It goes by both names there, right? So this is another really pretty nebula once we get an image of it. So we're doing 11 seconds exposures right now. It's another star-forming nebulae. Pretty much if it's in Sagittarius, I'm going to guess it's either an open star cluster or a star-forming nebula because we're in the arms of the galaxy. We're really close to the center. That's where the star forming is going to happen, is going to be in the arms of the galaxy, right, where all of that gas is. This one is really pretty. I kind of forget about this one until someone's like, hey, let's look at this. I'm like, oh yeah, that one exists. I feel like I'm just going to talk about dust. You can call this like a lecture on dust because you can see it's really bright in the middle there, right? And that bright area, that's where we're going to have a lot of star formation. And that those stars, they're lighting up the gas that's around them. So we do have some emission happening, right? We see some of this pink. Anywhere that we see any of this pink, there's a little bit of blue on the outer edges. I'm pointing with my finger as if you guys can see what I'm doing. But you can see like in this general area, right? That is gas that is glowing because the stars that are forming within it, they're radiating through it. But then of course we have this black, voidy, murky stuff, right? Like right around through here, right? Down here, this one's really interesting right there, right? And if we were to look at this in infrared, I really wish that we had an infrared telescope, like access to one, right? Wouldn't we all? So that's going to be dust. That's going to be colder, denser, heavier, bigger material, right? So it is blocking a lot of the starlight that's behind it. However, if we were able to take a picture of it infrared, you'll actually see there's going to be a lot more stars that are in there because that IR light is able to pass through, is able to basically just bypass these dust grains. It's so much bigger than the dust grains that we'd be able to photograph those stars, right? So for the person who requested the Lemon comet, apparently there's quite a few of them. So if you have, like, if there's a more specific designation, if you could give that to us, that would be great, actually. Yeah, so this is the Omega Nebula, or the not Triffid Nebula, the Omega Nebula or the Swan Nebula, depending on who you talk to, right? Well, yeah. I think the next one after so someone asked Jason Oxman, do all globular clusters have a black hole in the center? And there is evidence of several globular clusters that have black holes, or we're pretty sure anyway, like M15, which is one of my favorite actually, it is my favorite globular cluster. What am I talking about? Which Sarah might actually have just moved to. I looked away from the screen for a second, so I'm not too sure. Right. But M15, yeah, there it is. Hello, right? So M15 is incredibly massive. It's probably one of the more massive globular clusters that we have that's at least close by, right? I think this one's about 33 light years away. So I would say like almost on the other side, or just about the same distance as the center of our galaxy, right? And this thing has a radius of about 88 light years. We look at this one through the Clark telescope a lot when it's up, or we used to. So this one I can talk about forever if you let me. Right. But the really interesting thing is about, and its mass, I can't remember its mass now. Right. I think it's got about 100,000 to 500,000 stars in them. But about 90% of the mass of this object is concentrated in the very center, within like the first 10% of the radius, which is insane. And so what that tells scientists is there's some sort of really massive object at the center, and they think that it might be a black hole, right? But that doesn't mean that all globular clusters do have black holes. There are some that, we're unsure, and then there are some that we don't really have any evidence for that. But this does kind of support that theory that maybe globular clusters came from the nuclei of dwarf galaxies that have been cannibalized. Right? Yeah. All right. Looks like we're going to be looking at M13 next. So we'll go to M13. I'm trying to go back to where we were last. There we go. Yeah. All right. So M13 again is another globular cluster. Might as well just look at all the good ones at once, right? This one is one of the closest ones, right? It's about 22 light years away from us, and it's certainly one of the brightest ones. So this one is very easy to see with binoculars. We look at this all the time with our telescopes here at Lowell with our eyepieces. So this one is pretty popular, big popular one right there. So same thing, right? It didn't change too much from M15. This one is probably a little bit less massive than M15. I think there's maybe 50 to 100,000 stars in here. I could be wrong, right? But someone's drawing like a face on there. I'm not doing that. But yeah, so yeah, that's M15 right there. All right, let's go ahead, and someone asked for what? So there's a propeller that we're looking at right here in this in the center. I wasn't sure what Sarah was saying when she was asking about a propeller there. But yeah, it is a dark portion right here. I was not familiar with this propeller until just now. So yeah, you can see that most of the stars kind of they concentrate in this area, but there's a little bit of a void there. There might actually be some gas that might be blocking out some of the stars in there, right? There could be some nebulousness in there, which is pretty interesting, right? Yeah. Let's go ahead and look at Saturn. Real quick, because I saw Saturn up there. We both have Jupiter and Saturn, so if nobody objects, maybe we can just do both of those real quick right now. Right? Let's go ahead and let's adjust the exposure so it's a little bit lower so we can see the rings of Saturn. Oh, look what a cute guy. Right? Yeah. So yeah, we'll look at both of these. So Saturn's probably, I would say it's everyone's favorite planet. It's up there for me too. It's certainly one of the most picturesque images, right? You can see the rings pretty easily. You can look at it with a binocular and you can see the rings. And so the rings were discovered by Galileo. So Galileo was the first astronomer to look at the sky with a telescope, right? And he saw these rings and he was absolutely confused by them. He called them quote unquote ears, right? That's what he thought they looked like. so, so yeah, we have Saturn here. You can sort of tell it's a little bit fuzzy. I think we might have a little bit of humidity in the air. But it's also, we're doing a really bright object, right? You can see a little bit of the bands in Saturn. You can see it's light and then it also gets a little bit dark right there, right? So that's the atmospheric band. Saturn is a gas giant. It is the 6th planet from the sun. All right, and I think it has, oh, I'm probably way wrong because it keeps getting updated, but I think it has somewhere around 82 known moons. And Sarah, if we could try and get some of those moons, that would be great because I could talk about Titan, which is conveniently right there for us to see. You can always tell which one Titan is because Titan is this bright orange little moon slash planetoid thing, right? There we go. We can see a few of the other moons as well. So we have 1, 2, 3, and 4. That's what I see anyway. If there's extras, then I don't see them, but that might be one right there. Right. So there's 5 moons right there, and Titan is always the easiest one to spot because it's the biggest and the brightest, and it's always this like bright orange color. And it's my favorite moon in the entire solar system, and I wish it was a planet so I could say it was my favorite planet, but it's a moon, right? So what's really interesting about this is it's a little icy moon. It is bigger in radius, right? It is bigger than the planet Mercury. So this thing is actually planet sized. It's made of ice. It's made of various different kinds of ice, including water, right? And what's really fascinating about this is that this is the only known surface besides the Earth to have liquid on it. So the Earth has liquid water, right? That's what we need to live. If you were to visit Titan, you would find it's so cold that water is just frozen solid ice all the time. There's mountains made of ice on Titan, but the liquid on its surface is actually liquid methane. Excuse me, right? And it'll give like these kind of dark appearances, and it does have liquid like lakes and oceans and rivers, and there's even some islands. We got some really good photographs with Huygens when it dropped down onto the surface of Saturn, like more than a decade ago now, I think, right? Which was brought there by Cassini, which was going around Saturn for a really long time. And then, of course, it also has a thick atmosphere. The atmosphere on Titan is thicker at its surface than air is on Earth. So it's about, I think, 1.5 Earth atmospheres. And its atmosphere is about 98% nitrogen. So it's not good for us, but it's kind of cool. It's one of the only moons in the solar system to have an atmosphere at all, right? And the other 2% are going to be methane and ethane. So, yeah, so we got Saturn there, real pretty to look at. I always like looking at it through live through our telescopes here at Lowell. We're going to move over to Jupiter, and Jupiter is the only other planet that we can see tonight. So, if you like to stay up late, I like to stay up late. You can watch Mars rise. I think it rises about 10 or 11 or so. I've been seeing it on the eastern horizon when I walk my dog for the last time at night at about 11 o'clock. Right, but we won't be able to see Mars during this live stream just because it's not above the horizon yet. Anyway, here's Jupiter. We got some atmospheric bands. Again, we can see them really well, right? Right there. So all of these are a result of the winds on Jupiter. So again, gas giant, mostly made of hydrogen. However, that red you're going to find in those bands, that's going to be a little bit of, I think, phosphorus, if I remember correctly. So the winds are all going in different directions and different speeds, and so it causes the atmosphere to like line up and to make these atmospheric bands. And we call this rotational differential rotation. Wow, I got that out, I swear. Right? So like Saturn again, gas giant, it's going to be a lot more dense than Saturn. Saturn's not very dense at all. At the very center, it's kind of a mystery of what's happening there. Does it have a solid core? Does it have a liquid core? No one really knows. Leading theory right now is that it has a liquid metallic hydrogen core. I don't know what that means, but it sounds cool, right? So it's just under so much pressure that this hydrogen starts displaying metal-like properties. Right? So you could never really land on a gas giant. So if you want to visit Jupiter, you're going to actually have to visit one of its many moons. I think it has 79 moons right now. Again, these moons are constantly getting discovered, and that's changing all the time. So there might be more that I just didn't know about yet. But we're going to only talk about, I guess, 3 of them. I can see one up here, here, and then here, and then I don't see any other, I don't see the other one, the 4th one. But there's 4 that we can see from Earth, and we call these the Galilean moons, because again, they were discovered by Galileo back in the early 1600s or so. Right? He was the first one to look at a planet through a telescope, and he was the first one to see these moons. This is kind of interesting because during his time, everyone thought that the Earth was the center of the universe, and that meant that everything in the universe, the stars, the planets, the sun, everything revolved around the Earth. We're humans, we're selfish, we want to be the center of everything, right? But Galileo, he was watching these moons that he discovered, and I don't know what he called them at the time, right? But he was watching these moons, and they were changing like the planets, right? But he was watching, and it was pretty obvious that they were going around Jupiter. This is the first evidence that pointed to something not going around the Earth. And so Galileo, of course, was telling everyone, he's like, hey, these moons are going around Jupiter. They're not going around the Earth. In fact, I don't think that the Earth is the center of the universe, right? People were really upset about it. And they got so upset that they actually put Galileo under house arrest for the rest of his life. So, yeah. I particularly like Galileo. He's one of my favorite scientists, so I could talk about him forever. I think one of the big reasons that people didn't want to listen to him was because he was kind of a jerk, right? But at least from the from the biographies that I've read from him, he was pretty abrasive to work with. So I can see why people probably wouldn't want to listen to him. But he was one of the first experimentalists. He was the first person to look at space through a telescope. He made a lot of big discoveries. And so he was a very important astronomer. All right. Yeah, so that's Jupiter and Saturn. We're going to go ahead and I want to look at M20, I think is the next one that was on the list, or actually those comets. Comet Lemon, we actually have we have the coordinates for Comet Lemon now, so we're going to enter those in and we're going to look at it. So this one was discovered in 2019, it looks like. So we're going to go ahead and look at it and we're going to see what's so great about it. And then after Comet Lemon, we'll look at M20, and then we're going to look at one more object, and then we're probably coming up on time here. So we're going to have to start doing the long exposures on that. Yeah. All right, let's up that exposure a little bit. I am not seeing too much yet, just like the dust on the computer screen. I know a few stars. So yeah, this is lemon with 2 M's. So not like the delicious fruit. We're at 20-second exposure right now. There it is. Oh yeah, you can see the bright center there. That's going to be the coma. And then of course we have this outgassing around it. You can see some like nebulousness kind of like around this general area right there. And so that's going to be, again, that's going to be ionized gas that's coming off of this comet as it gets close to the sun. It starts to heat up and it starts to sublimate. So this one is a lot further away from us than the other one that we were looking at. I forgot what the other one was called. You know, the one that were Neowise, right? So this one's a lot farther away, so we can't see this one with the naked eye. We had to do a much higher exposure. We're doing 25 seconds now, trying to get a really good picture there. I think that talking about comets can kind of help me segue into what we can look forward to next for Lowell Observatory. So next Tuesday, we're going to have another live stream. There's another meteor shower that's happening, the Perseids. Perseids are personally my favorite meteor shower. I really like going out and watching them. And I swear, I think this will be the first time that I'm going to be watching them and I don't have a full moon in the way, because I always feel like it just happens to be the full moon when they happen for me. So it should be, as long as the weather stays good, we should be able to see some pretty good meteors. And so the reason that they have to do with comets is because the Perseid meteor shower and all other meteor showers, those are caused by the Earth passing through comet tails. So when these comets pass by the sun and they leave behind these tails, those stay in space and the Earth will pass through them, right? Because they're in the way. And these little pieces of ice and dust, they'll pass through the Earth's atmosphere and they burn up in the atmosphere once the pressure becomes great enough, and they light up. And so those are what we'd also call shooting stars or falling stars. Right? So we have this live stream that's happening next Tuesday at 9 p.m. Pacific time or Arizona time, right? And we'll have astronomer Nick Moskovitz as well as Mike Henke and Megan Jaluka are going to be doing that live stream next week. So you should go watch that. We're going to go ahead and we're going to look at the Cocoon Nebula. So this is also known as IC 5146. We're going to see, so this is again another nebula that I'm not sure I've actually seen. I'm kind of excited to see what it looks like. Again, she has to enter the coordinates for this one, and that's because we don't have this one in the catalog. So we weren't able to do a search function for it this time. So Fortunately, the telescope moves quick enough and we'll be able to look at. So that's still our comet. We're going to have to probably change the exposure time. Not sure how long we're going to need yet. You can see these lines in the image. Those are going to be a result of the telescope moving, actually. So we'll get little star trails if it's taking pictures while the telescope moves. So we're doing another long 25-second exposure just to see where we're at. There it is. So this one looks like it's another star-forming nebula. Maybe we could up the contrast a little bit on that one, just to see if we can pick out some of the colors there. But I see a lot of red and a little bit of blue, right? And I don't need to be looking at the spectra to know that that red is going to be hydrogen gas. So hydrogen is the most abundant element in the universe. So if you you could probably point in some arbitrary direction and be like, that's hydrogen, and you'll be like 80% that you're correct, right? So we can see this pink hydrogen gas here. And then of course, there's this dark nebula that's sort of in front of it. And of course we have these foreground stars as well. So those brightest ones, those ones are going to be in the foreground. And well, yeah, you can see some of that dark nebula, that void going on in there, right? And again, it's not empty void. That's going to have a lot of stars behind it that are getting blocked by this dust. And then, of course, I can actually see a little bit of blue. I don't know if that's just the quality of the image, but I can see a little blue in sort of the outskirts here. So we might actually have some oxygen as well. Those are going to be the most common things that we see emitting in these nebulae. So I can confidently say, oh yes, hydrogen and oxygen, right? Yeah, this one's real pretty. Another star forming. Yeah, it does, right? So another pretty star forming nebula, right? All right, so we're gonna have one more object that we're gonna look at, and this is gonna be the Triffid Nebula, right? We always save the best for last, obviously, right? So we're gonna go with the Triphen Nebula, again, another one that's in the Sagittarius constellation, and it's another star forming region. It's gonna be filled with some more H2 gas, as well as some other lighter elements in there. I've forgotten what it looks like, so I can't wait to see it. When I look at it, I'm like, oh yes, that's it. Absolutely love the dark nebula right there in the foreground. In the front, you can see this black, right here. Oh, yeah, you can see this dark nebula here in the foreground, and of course, you can see some of this blue on the right-hand side, right over here, and a little bit of blue in the center there, right? So this blue over here on the right-hand side, that's going to be, that's actually a lot of gas that's going to be reflecting light. It's not emitting, so that's going to be starlight that's kind of bouncing off of it, right? But over here in the red's going to be where we're seeing emission happen. So again, those hydrogen atoms, those little electrons are kind of just bouncing all over the place, right, as the light hits it. So we're seeing some emission, and of course, this dust, which is my favorite thing in outer space. And all of space is dust, right? Yeah, so again, this nebula is collapsing in on itself. It's forming brand new stars, brand new baby solar systems. I feel like we come full circle because we looked at a star forming nebula very first, and now we're looking one at the very end. But that does reach us to the end of our time. So I do want to just thank everybody who watched this live stream tonight. Thanks for everyone for joining us. Y'all had some great questions. You stumped me with a few, and I'm pretty excited about that. But don't forget, we have our meteor shower live stream happening next Tuesday at 9 p.m. We are also continuing with our Cosmic Coffee episodes and our Meeting Astronomers. as well. So you should also watch those. And yeah, I want to thank everyone and have a good night.